Hey, my doggy, he's back. Woohoo! Yay! Hey! It's Mr. Warrior here at your service. Actually, he's just my avatar. That's not really me, but he's so cool. You know, I like this avatar so much, I think I'm actually going to give him a name. That's right. I decided I'm going to call him Max. That's right. Oh, Max. You know, get it? Get it? The Grinch. Hey, anyway, Mr. Warrior here. Time to get a little bit serious. I'm a little bit crazy this Sunday evening here. Let me go ahead and let's take a look at our plan. Our plan being what we're going to be looking at today for math. I know you guys have missed these math videos, haven't you? You're like, Mr. Warren, we did not have a math video on Friday. We want you to know that we really missed it. Anyway, well, get out the tissues, my friends, because you won't be needing them for today. We're actually going to be doing the exact same objective. We decided to take this lesson and break it up into two because we have word problems and we wanted to spend a little bit extra time doing that along with other activities. Anyway, it says that we're going to solve a division word problems involving multi-digit division with group size unknown and the number of groups unknown. Basically, we don't know very much, do we? According to this objective, we're going to solve these problems, however. And, oh my goodness, what's this little thing here? Looks like a weird little thing here. What's it doing here? You know what? Let me see. Woo! It's a dog! Yeah! There's a little dog just kind of sitting there. Right on, doggy. Why don't you just sit on over there? Well, you know, we'll make it a little bit bigger. You know what? Yeah. Is it any clue that Mr. War likes dogs? I guess. Anyways. I like cats, too. Not really. No, I do. Anyway, let's go ahead and get to the problem here and let's take a look and see what we have. We have Alyssa's dad. Hey, is building her a treehouse so she can use a telescope and see the stars and invite all her friends. That would be really cool. Nice. It says that he cuts 18 pieces of wood from a board that is 186 inches long. Okay? He cuts 9 pieces that measure 12.75 and then inches each, and 9 pieces evenly cut from what is left. Oh, you again. Goodbye. Jim calculates that due to the width, I'm sorry, Jim, that's not that. We need to put it right here. A quick change. As you can see, I kind of changed my problem. Shh. Hey, don't tell anybody. Okay, so anyway, so Alyssa's dad, like that? I know, it's pretty cool. Alyssa's dad calculates that due to the width of his cutting blade, oh, you're in my way now, doggy. Move your tail. He will lose a total of 1.5 inches of wood after making all of the cuts. Now, what is the length of each of the 9 pieces? Oh, my goodness. Now, I'm sure you're thinking to yourself, come on, Mr. Wara, this is a 5th grade problem, and I'd have to say, yeah, it is. So, what's going on here? What's happening? Well, let's just slow it down. Okay, first of all, we're going to just go ahead and point some things out. Let's point this out in red. Okay, obviously the whole first sentence doesn't really, apply, to the problem. It's given us a little bit of background, the purpose of why Alyssa's dad's cutting wood. But it says here, let's slow down. It says he cuts 18 pieces of wood from a board that is 186 inches long. Okay, so it looks like now, here's my 9 pieces. Here's another 9. So here I have 9 pieces here, and I have 9 pieces there. And you can see that he's cutting 9 that are going to be this size, and then he's going to be cutting 9 that just says they're going to be evenly cut from what is left of the actual board. So getting that out of the way makes this problem a little bit easier when we look at that. And Alyssa's dad calculates that due to the width of his cutting blade, and the width, it's just referring, so you got a blade that's cutting, right? And so it says he's going to lose a total of 1.5 inches of wood after making all the cuts. So let's go ahead and start off this way. Let me go ahead and get my tape diagrams. We're using these things all the time. Let's open this one up. Ooh, make him a little bit skinnier. There we go. Make him nice and long there since we have this long piece of wood. So this is what I'm going to do here is I'm going to go ahead and take this step by step. Ooh, let's get another color other than black. Thank you. Like blue. Blue will work. Okay? And here, basically, we're just going to say this is the wood. Okay? This is the wood going down. And basically, we're going to make any cuts this way. It says that he's going to be cutting 18 of them. But first, let's look at the 9 pieces. Let's just deal with this one first. We know this whole length, though, however, if I can do this, is going to be 186, and you could do the two little thing here, that means inches. I'll also write it over here, as not to confuse. Mr. Aura does not want to confuse you, no siree. Now I'm going to come over here, and let's go ahead and start saying, well, if we're going to cut pieces, we're going to be cutting pieces like this, right? And in here, we're going to have 12.75, okay? And then you're going to have another one with that, okay? And we need, actually it says we need 9 of them. So I'm just going to say 2, and then I'm going to kind of do this. I'm going to go 3, 4, 5, 6, 7, 8, 9, something like that. And it's going to kind of keep going. Now, keep in mind that one 186-inch piece of wood here, we've also have other that are going to be evenly cut as well, okay? And we don't know what that amount is yet. Also, one last thing, and let me get a different color here, and that is that, remember, we're going to also be taking off 1.5 inches, okay, due to the width of the blade, okay? I mean, you can't really cut these perfectly without having some kind of little bit of loss of the wood, because the blade itself is wide, so it's going to take off a little bit there, if that makes sense. Not crucial in the problem, but, well, it is crucial. It'll make a difference of whether we get the right answer or not, but so now basically, so we have these 9, as you can see, and then we have our 1.5, and then these are just all the other 9 in here. So it should be a total of 18 when we get done, 18 pieces here. So let me go ahead and start off. Well, let's figure out how much of the wood would be the 9 pieces of 12.75. Well, that's simple multiplication here, right? We can just multiply that by 9. That's 45. Carry the 4. 63 and 4, I believe that's 67. Carry the 6, we have 18. That would be 24. Carry the 2. 9 times 1 is 9, plus 2, 11. I surely hope so. And we're going to multiply that by 100, right? Our way of getting rid of that decimal and making sure that we divide it by 100 again to bring it back here to the 114.75. So this is what the amount of wood is going to be used for those 9 pieces. So basically, what we could do then is to figure out the rest of this then is, since these are evenly cut, we could take the total, which we would have here, basically, and subtract this from what was the total. So this 114 and 75 hundredths, we could subtract that from the 186. And why I'm subtracting that is because this is showing this amount in here of just that wood here, okay? And those 9 pieces, I should say. When I say that wood, that's what I mean. So I'm going to go ahead and subtract 114. Now, this is interesting. When a problem like this comes up, we always have to line up the decimal. You say, Mr. Warren, you didn't line it up correctly. Well, actually, 186 can be written as a decimal. We can just add those 2 zeros on. Okay, now we can go ahead. I'm just going to grab another color to make it a little bit easier to see here. So we have a lot of regrouping that we need to do here. So I'm going to go ahead and get 1 from here. That brings him down to a 5. That gives him actually 1 whole. Okay, now he's got 10 tenths. That's going to move him to 9 because he's going to 1/10 to that. So basically we have 5, we have 2. Bring that decimal straight down. We have 1 and we have 7. Okay, so I'm coming up with 71 and 25 inches here. And basically that's what's going to be left over. So if that's the amount that's left over, now we can divide that number, okay, by 9 to see what, because the problem says 9 pieces evenly cut from what is left, and what was left was the 71.25. So let's go ahead and take the 71.25, and we're going to go ahead and divide that by 9. Put that decimal up there, and then basically, we also, you know what? We also have to take off 2 inches. I forgot to take that 2 inches off. I should have done that there. Let me see. You know what we'll do? We'll take the 2 inches off here. Okay. So I don't want to be any problem with this here. Let's just go ahead and do this problem again right here. Whoa, redo. So yeah, we can always do that during math. No big deal as you're going along the way. Because remember that 1.5 inches, so we want to take that off the 186 first. So here's your 0, and we'll take that off. Okay, that's a simple subtraction problem. And there's 5, because you need some help over here. So we have 5. And it looks like 184.5. I'm going to go ahead and erase this other one too. Get out of here. Goodbye. Get up. Scat. All right. And now we come up again. So now we have our 184.5 0.5, and then we're going to go ahead and subtract that same amount, 114.75. Okay, and let's see, we need to regroup in all the way. My goodness, we have to come all the way over here. Okay, and we're going to give that one there, and then that's going to go to 13. You can get 1. It's going to go to 14, and 1, 5, 7. That looks like 9, and that looks like 6. 69.75. Let me see here. I can double check my work by going 5, 5, 10, carry the 1, 4, 15, carry the 1, 13, 14, carry the 1, 7, 8. Looks good. I like it. So now I'm going to go ahead and take that 69.75, and I'm going to divide that by my 9 now, because remember, this is what's left over. Now, you were watching this going, Mr. Wara, you are totally confusing me. Well, we're just going to think back what we did here. We took the 9 pieces that were cut here, and we just multiplied them, and that gave us that amount. We took this amount, okay, and also the 1.5 inches that we need to take off because that's what's lost, okay, due to the cutting. So we took that off the total, giving us 184.5. Then we subtracted that amount that we have here. This is what's left of that wood. This is what's left. And we're going to divide that by 9. Well, 9 goes into 69, I believe, 7 times. That gives me 63. Now we have 6 down here, as we subtracted. Break down to 7. Again, looks like I want to say, wow, 7, 63, 8, yeah, 7 again, 63. Okay, bring us down with a 4. Okay, and then I got to bring down my 5. And now 9 goes into 45, of course, 5 times. Look, we have 7.75. So basically, what were they asking us? Well, it said, what is the length of each of the 9 pieces? Well, of those 9 pieces that we didn't know, remember, this is what we didn't know, okay, which is right here. They told us this number. So we get 7.75. Now, if we look at our equation from this standpoint, we'll just move him over here for the time being. Let me rewrite this so you can see the whole thing together. So basically what we're saying is this. We're saying that in this case, that the 114.75, those were the 9 pieces of wood, right? Remember? Okay, if we add that 1.5 inch, remember that was the part that we took out because it was the waste of the wood from the cutting. And then also, if we go ahead and add, see, the amount of units we had here were 9. See, that's going to equal that total of 186. So basically what we did, we took this number, and in order to find out what, this should have been units, sorry, don't think this is 9 units. It's like an X, right? We don't know what it is. And so what we did was we subtracted this from here, we subtracted that from there in order to find out what that 9 pieces was. Okay? Are we okay with that? I hope so. Okay, and now we're going to go ahead and go on to the next page. Wow! Hey, he's a bigger size of the same dog. Yeah, how you doing? Yes, I like you, doggy. How you doing? But you know what? I am going to give you bigote. There you go. Woo. Maybe you need some hairs up here. Okay. Oh, I'm tired. My eyes are bloodshot. Okay. All right, let's go ahead and hit group. There you go. I'm going to shrink you down. All right, another problem. Here we go. Dun, 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 dun. Okay, this one here. Oh my goodness. A load of bricks is twice as heavy as a load of sticks. I would hope so. Sticks, bricks, yeah, twice as heavy. That's kind of when you say twice as heavy, we're thinking, right, times 2. Keep that in mind. The total weight, okay, of 3 loads of bricks and 3 loads of sticks is 618 and 75 hundredths there kilograms. Wow, 618.75 kilograms. That's how we would really say that. So then what would the total weight of 1 load of bricks and 3 load of sticks? Wow. Now, I'm going to be honest with you. When I first looked at this problem, I'm thinking, you know, this is like middle school, high school algebra here. System of equations is what came to my mind. However, don't worry about that. We're not going to be doing that. So instead, what we're going to have to do here is we're going to have to find another way to solve it, not like so much using algebra. So I kind of think of it this way. Let me do a couple long. Let's just say this is kind of the length of 1, and then I'm going to do this and make a copy. Ooh, I know. Wasn't that cool? I knew. And make it about the same width, so to speak. I don't mean that one to be a little bit, let's see, yeah. We'll see how this works out. That looks like about the same, okay? And so what I'm thinking is the only way we can do is we can compare the two. Let me show you what I have in mind here. First of all, let's look at this problem here. One thing that we know is we know that 3 loads of bricks and 3 loads of sticks is equal to this amount. So using our tape diagram, this is kind of what I'm kind of thinking here. The tape diagram that you could solve this is, since there's a double going on here, saying that times 2. So what we could do is like, we want to try to find a unit. So let me just break this up into thirds. Okay, and we're going to call this one down here the sticks. Okay, you are the sticks. And up here, you guys are the bricks. Okay, and I'm going to compare them side by side or back to back here, if you will. So for every one load of sticks, I should say, for every 1 load of bricks, you actually have 2 loads of sticks that equal that. What I'm trying to say is this: if 1 load of bricks is twice as heavy, then that would mean you would need 2 loads, okay, of sticks to equal 1 load of bricks. Does that make sense? So this is important. 1 load, I'm going to write of bricks. So all I'm going to suggest is that let's go ahead and say that these are the 3 loads of sticks that we have here. So then we're going to actually need 1, 2, 3, and then we're going to have 3 more. So we actually have 3 loads of sticks here, and then we're going to have 6 loads of bricks. Okay? Now, don't be confused. There's a total of 6. I'm just showing that the weight, it's the same as 2. This is the same as 2, and this is the same as 2. Okay? Everybody's okay with that. We're just getting, because all of that, when it's all said and done here, all this amount here, that's not a very pretty little bracket there, Mr. Wara. I think it was because you were talking, you weren't paying attention, so let's try that again. I like to do my, ooh, something like that. Okay, ooh, it looks like a face with a chin and a nose. Okay, so let's go ahead and say that weight then is 618.75. So what I'm trying to do here is I'm saying that we're just doing this model here so that basically we can kind of come up with a unit. So if you look at it, we have 1, 2, 3, 4, 5, 6, 7, 8, 9. 9 units. So basically 9 units then is going to be equal to, let me fix that. Okay. 9 units is going to be equal to, I'm getting back my pen, is going to be equal to the 618. Okay, 0.75. So what we need to do is we need to find out like what one of these units are. Well, that's good old division, right? When we want to find that, so, all right, doggy, way up here now. 5, oh, going there 5 times. So we ended up with 68.75 for 1 unit that we have here. Now, this is what we're going to go ahead and figure out now. Okay, so if you remember what we talked about, we said for every load of like 1 stick, okay, it's like having 2 loads of bricks, because 1 brick is equal to 2 loads of sticks. So that's how we kind of decided this, to set it up this way. So basically what we're going to have then is we're going to have our 3 loads of sticks, which is going to be the unit here, 1, 2, 3, okay? But for 1 load of bricks, that's going to be, remember, double, twice that, so we're going to have 2. Okay, so now basically we have 5 units then. 68.75 times 5. 5 carry the 2, 35, that's 37. 3, 43. Now we have 30, 34. And now we have 2 decimal places. So it's going to be 343.75. And this is based on this information that we have here trying to set up as a unit. Now, there's another way that you could solve this, and maybe this might make a little bit more sense. So I'm going to go ahead and I am going to do this. And then basically, I think when I think of trying to solve this problem, I think this is important here. Think of this, 3 loads of bricks. This might make more sense to you. 3 loads of bricks and 3 loads of sticks equals this amount. Well, if we were to write that, think of that like 3 being the loads and the B for the bricks. Plus, and then it says 3 loads of sticks, let's just use S, is going to equal 618.75. Okay, now this is 3 times, okay? Remember, this means times. So whatever the one load of brick is, we're multiplying that by 3 times. Here, the same thing. Now I want you to kind of think of it this way. The problem says the bricks is twice as heavy. So when I look at that, immediately I'm thinking, okay, well then that means in order to get one load of brick to be the same as one load of bricks, I need 2 loads. Okay, is going to equal to 2 of the sticks. Okay, and I'm writing this fast here because I don't know where I'm at with my time. Okay, so 1 load of bricks is equal to 2 loads of sticks. Therefore, when you think about it, 3 loads of sticks for the bricks would really be double that, which would be 6. Are you with me on this one here? So what I'm going to do is I'm going to change this into the same unit as the sticks. So if 1 load of bricks is equal to 2, that's almost saying like 1B is equal to 2S. And therefore, I would need 3 of them. Okay, and this is a 2S. And here's my another load of bricks is equal to 2S, 2 loads of sticks. So really, 3B is equal to 2, 4, 6S. Now, did I lose you? I don't know. And if you think about it, that's kind of the same thing you're doing with a unit. Okay? This is if you're doing like an equation. Now suddenly, if you add these together, I have 3 S's over here, 6 S's over there, it means I have 9. Now, I'm going to do that same division problem I had. Okay? And now, when you divide it, we already figured out the problem, and the answer was 68.75. So 68.75. Now, that's technically for 1 load of sticks. And now, we're supposed to find out how many loads of sticks? 3. So we could take 68.75, multiply it by 3, 15, 21, 22. Let's see, that's 24, 26, 18, looks like 20. Okay, and remember I have my decimal place to move in, 206.25. But I also have 1 load of bricks. But remember, 1 load of bricks was the same as really 2 loads of sticks. So you could take 68.75, multiply that by 2, and 16, 17, 12, we have 137.50. Now we can add that on to our 206.25, and 13, carry the 1, 4, and as you can see, we get that 343.75. That makes sense? It's a lot. Let's see here. How are we doing here? Time to put this thing to a close here, I believe. And I don't think I've given you everything that you've needed. Oh, it's trying to do that. Well, actually, maybe if I do it really slow. See? There you go. And I think that covers it. I have to go. Okay? And see you later.